All right, so this lesson is going to involve inverse functions. So let's get started on that today. As always, guys, make sure you're watching the video on your own. And our objective today is going to be defining and using inverse functions. So let's move on here. Let me bring the chat up on my other screen. All right. So basically, when we're thinking about inverse functions, it's the idea of, as we learned for the other one for functions, we're going to have some type of output, and usually it's called like function f or whatever, and it's going to have an input. So the input is usually something that's independent that we want to kind of use as a measuring. So in this case, they want us to know find or speed determined by the function. So in this case, it's a fee. They're charging people money for speeding. So X is going to represent the speed of the car. They're going to subtract this much from it. But what if you're given a ticket that already has a specific cost? So if you already know what the fine for the ticket is going to be based on your speed, you can backwards engineer it to figure it out. And that's not just a matter of just plugging into y. You can just create another equation, and that's what these inverse functions are going to be. You have the output already. You want to figure out what the input was. So in this example, if you have $230 as a ticket, you can plug the $230 into an equation and do that instead of having to go. I'm going to have to add the 410. I'm going to have to divide by 8. You'll already have an equation that you can just plug it into. So that's what inverse functions are. So here, when we're talking about an inverse function, the interesting part about inverse functions is if you put uh, an inverse function into a function, you'll always end up getting x. So the easiest example, like they give this example where if you subtract 2 and divide by 7, that's going to be the opposite of what we did here, which was multiply by 8 and subtract that. So basically, the idea is if you have an inverse function, if you put that inverse into the function as an input, you'll end up getting x as the output. So here are the functions that they gave us. So multiplying by 7 and then adding 2. The opposite of that would be subtracting 2 and dividing by 7. So whether you do it g into f or f into g, you're going to end up getting x as a result. So going further into that, that's going to switch our x's and y's up. So if you see here, if you plug in a -2, you're going to end up getting -12. If you plug in -12, you'll end up getting -2. It's literally just opposite. We're just flipping it over. As I said before, if you guys can give a thumbs up or just type in yes in the chat just to kind of agree or disagree if you understand what inverse functions are, let me know in the chat right now. Cool. All right. So that's pretty much it. Just literally just doing the opposite. And here they kind of break it down step by step. Multiplying is the opposite of dividing. So that's why everything's kind of done a little differently. So since multiplying is the first thing we do here, it's going to be dividing is going to be the last thing we do there. Since adding is going to be the last thing, it's going to be the first thing we do here. And it's vice versa. So that's basically how we figure out a function. I'll kind of list how give you guys a series of steps you can do to figure out a function. And here it's just giving us a different scenario here where it's saying like, oh, if it doesn't pass the horizontal line test, it'll pass it here. Just because since we're getting 2 points in here, it's gonna. I don't know why it explains it this way. Let me just let me put my pen out here and I'll kind of like explain it a little bit better. Sign in with Google. Because they're trying to give you a visual display here, but it kind of doesn't make sense. So let me do it with my pen. Ugh, signed into the wrong one. Where's the log out? Sorry about that. There we go. Now I'm able to do it. So basically what ends up happening here, oh, I have my board upside down. I was like, what's going on? What's happening here is because we're switching our X's and Y, our graph, no, that's fine. Our graph ends up flipping over. So if it doesn't pass the horizontal line test, it's not going to pass the vertical line test for the inverse. So that makes sense. We're switching our X's and Y's. So what used to be our X used to be our Y. So it kind of does this 45-degree tilt. And let's move on from here. Let me delete this. So remember the theorem, increasing and decreasing. So this is just saying that if it's decreasing on the Y, it's going to be increasing on the Y for the inverse. That's all this is pretty much saying. You're just switching your X and Y. It does go into a lot on like domain and range. For example, if we have a function here, so this is actually really important for remembering for domain and range. So your domain for a fraction, it's always going to be the bottom, so your denominator has to be greater than 0. Or I'm sorry, I'm thinking about roots. Your denominator cannot equal 0. So there'll be points in a graph that cannot equal to 0. And here, the one they're actually talking about here is, even though this is it's annotated as to the -1 power, it's not really the -1 power. It's just saying that the function is an inverse. So that's a little confusing because this would be saying that, oh, it's literally to the -1 power. If you guys remember from exponents, if you have a negative exponent, it goes to the bottom. But if you're saying this is just saying that's the inverse of the function. It's a little weird. I know. I don't know why they do that, but that's just so you guys know this is the notation for an inverse function. That domain stuff, we'll get into that a little bit more. They talk about it here. The domain and the range end up flipping. I apologize. I thought they were talking about when we're talking about domain and range here, but that's also a good side note to have. Do you guys kind of understand the notation of inverse functions? I know it kind of went off on a tangent there. Yes, no, maybe? Cool. All right. So moving on here. So the steps to doing this, it's a 4-step method. I like it. Um, Technically, it's only 2 steps. The only reason why it's 3 steps is the labeling part. So the first part that you're going to do, so let's say we're taking this function right here, is you're going to switch your f of x to a y, and then you're going to solve for x. And actually, you can even actually like this method better. Usually what I do is I change my X and Y and I solve for my new Y, but I kind of like what they're doing. So what they're doing is like, okay, cool. We did this. Now we're going to solve for X, meaning we want to isolate X. We just want to get the X by itself. So that's what they're doing here. They're like, okay, cool. So we're going to subtract by 4. Then we're going to divide by 3. And then what we're going to do is we're going to change our x to become our y. So changing x and y, that's that whole idea I said here where this is kind of reflecting off of that 45-degree angle, and our x and y just switch places. I was supposed to be pointing at the x-axis and the y-axis here, but I guess that works out that it kind of looks like the line flipping over because that's what's happening. It reflects. Let me erase all this. So that's the easiest way to kind of solve for the inverse is just plug in your y for your f of x and solve for x, switch it out. And instead of writing this as your new y, you're going to write it f inverse of x. So again, this is the inverse sign. And that's the step. So I recommend remembering this step page, this screenshotting it or whatever you need to do. 12 out of 29, I think it's going to be very useful in doing this. So here we're going to do a different one. So they want us to solve for the inverse of this. So in order to do this, it looks complicated because we have a denominator, but it's not that bad. What happens here is in order to get rid of a denominator, you're going to multiply both sides by the denominator. Here you're going to distribute your y. And then what you're going to do is you're going to add your xy to both sides. So let me get my pen out. This xy is going to be added over here, and that's how we get it there. Or let me do it so you guys can see it here. And you're going to subtract your 3. So you're going to move that over here by subtracting. And in order to only get one x, what they're going to do here is they're going to factor out that x. They're going to take the x out right there. That way, now you only have one x. And now that you only have one x, you can divide it out. So just make sure that when you're doing this, when you have a fraction, you're going to have to do some factoring. So whenever you see something like this, where, let me highlight, where you have an x, two x's, somewhere down the line, this tells you you're going to have to factor. Once you get all this down, then it's just as simple as flipping this. So this solve for x part has a lot of nuances to it. You're going to have to factor if you see two x's somewhere down the line. And if you're dealing with fractions, you're going to have to involve multiplying that denominator to both sides as well. So, you guys good on this one? Yes, no, maybe? Cool. All right. And next step. So moving on here, they want us to solve for the f inverse. Okay. So according to the first step, I'm going to change this f of x into y. And now I want to solve for x. So first I have to get rid of my denominator. So I have to multiply both sides by 3. So now I have 3y equals 2x minus 5. The way I always solve for a variable is I think I want this. But before I get that, I have to do this. And before I even get to that, I have to do this. And in the case of the top one, before I even got to do that, I had to deal with that 3. So that's just an interesting way of thinking about how to do it. A lot of people think reverse PEMDAS, but sometimes that doesn't apply because, I can't undo these. There we go. Sometimes that doesn't apply because, for example, this one, this 3, how did we know we had to deal with that 3 first? Technically, you would have to pretend that there's parentheses, meaning the parentheses would go last. So before that, we're going to have to do this. So I like thinking of that little circle method, but let's carry on. So now we have to add 5 to both sides. Add 5 to both sides. These are not like terms. This 3y and that 5 are not like terms. So it becomes 3y plus 5 equals 2x. And now we have to divide by 2. So we get x equals 3y plus 5 divided by 2. And we're going to switch our x and y. So that becomes y equals 3x plus 5 over 2. Again, the second step is the most important, guys. So once you get to this point, you can pretty much just go like, oh, that's going to be an x. This is going to be f inverse of x. So after that, you can pretty much just go over here and be like, oh, it's going to be this one because we're adding the 5 to it. Oh, actually, they do trick you here. So don't forget to change this right here. This is what makes it wrong. So you're going to want this one. So I guess they are really testing you to see if you know that one step. So carry on. If you guys are just taking notes right now and you're going to do this later, just remember that they might shuffle these. They might not. I honestly don't know, but just make sure you're paying attention to how we do this. All right, so moving on here. Now they want us to find the inverse. They're saying this part, a lot of people always ask me, like, what does it mean when they say this? I'll explain that when I get there, but usually what they're saying here is we're going to assume that it's always going to work. So this is just usually something telling you, like, hey, just so you know, they're like, if you're dealing with a square root, or something, we are only going to talk about the ones that work. We're not going to deal with imaginary numbers. So that's just kind of like a little confidence booster there. It's like, don't worry, we're fine. We're only going to talk about numbers that actually work. So that's usually why it works. So here, y equals square root of 7x plus 2. Oh, and actually, I can tell you that right now. So if you multiplied it by 7, it cancels out, it becomes negative 2. Negative 2 plus 2 is 0. So you can take the square root of 0, but you can't take the square root of anything smaller than 0. So that's what it's just saying. It's just like, hey, we're only going to be talking about the x values that work here. Sorry, I know I keep going back and forth. So now going back to this one, the only way to get rid of square root is to square it. I'm going to start trying to use different colors. That way you guys can see the new steps. So from here, we have y squared equals 7x plus 2. Now we're going to have to subtract this 2. These are not like terms, this y squared and that are not like terms. So we end up getting y squared minus 2 equals 7x. We want to get rid of that 7. So we divide by 7, divide by 7. Now we have x equals y squared minus 2 divided by 7, switching our x's and y's. And inserting that inverse sign, which in this case isn't even necessary because they don't even acknowledge the inverse sign. So you won't need the fourth step for this one. So here we're looking at x squared minus 2. So here we have x squared minus 2 divided by 7. Are these problems making sense to you guys? Cool. All right, so let's move on to verifying and graphing inverse functions. So again, they're showing us the 4 steps. The verification is, again, uh, this line that I keep drawing is y equals x. And the reason for that, if y equals x, then x equals y. So it's its own inverse. which because it's its own inverse, anything that reflects here will reflect over here. So here you see 0, -2. That means it would be 2, 0. Oh, I said -2. I meant 0, 2. So over here it'd be 2, 0. So you see that everything kind of just reflects over. Our x's and y's are reflecting. So this is our line of reflection. So that's what's going on here. That's a good way to verify it. Is if it looks like our x's and y's changed, then that means our x's and y's changed. Um, Graphing, again, graphing just looks that way. So that's a good way to kind of check it. So moving on. Reflecting it algebraically. So basically, what they're saying here is if we put the function into our inverse, it works out. So here, if our inverse is this and our function is this, if we plug this into the x of here, we should end up getting x. And they're working it out here. So we have to find the cube root of x minus cube root of 2 minus x. So they're just putting this in there. So if we carry out the negatives, I don't like how they do this. If you carry out the negatives, this is going to cancel out. So that's the step they're kind of not showing you, is that the 2's cancel. And the cube root of a cube is x. So that's all that's happening there, is they're just verifying it. And another step 2 in verifying it is now we want to put the inverse. So we're going to put what I'm going to put in yellow into the x of this one. So if we do that, it's going to be 2 minus cubic. So this one's actually really easy to do because the cubic the cube cancels out with the cube. And then after we distribute that negative, so they're not showing us distribute the negative, the 2 minus 2 plus x turns just into x, meaning that we verified it. We verified it one way and we verified it the other way. So that's a good way to verify if your inverse really is an inverse. Plug one into the other. Plug the inverse into the function, plug the function into its inverse, and you should end up getting only x afterwards. All right, so moving on. So here they want us to show the steps of these. These are honestly very hard to do on a keyboard, but I'm going to try to type it out for you guys. So verify whether these two are functions. What is g with an input of f of x? So in other words, they only want us to verify it one way, luckily. So if we're doing this, we're going to write f with, or I'm sorry, g with f of x as an input is equal to the parentheses. Since we're replacing the x, oh, since we're going to, I realize we're doing the g. So they want us to do the g. G. So we're looking at the G and we're going to input the F into that G. So looking at this, I'm going to want to start off with a fraction. And I'm going to start off with minus 5 minus. And I have another fraction right here. So I have to put a fraction within a fraction. And that's going to be x plus 5. And then at the bottom here, I'm going to put 2x plus 1. I'm going to close this, close that. And basically what's happening here, let me grab my pen. is instead of writing this x, I'm going to write all of this. So I know this is a lot. This is why I recommend when you have the opportunity, this one, unfortunately, you can't use pictures. Oh, and I really hate this. For some reason, it doesn't make your parentheses bigger on Edmentum. And then right here at the bottom, we have 2, and we're going to multiply that by this big old fraction over here again. So I'm literally just going to copy this. So I do Control C, so here, Control V, and it copies it perfectly for me. So I don't have to even bother worrying about if I inputted that correctly. I already did all that. So I don't have to re-input stuff that I've already inputted. Then I'm going to minus 1, and I'm going to close my bottom. So the first thing we have to do is this one, we would have to multiply this 2 out. And we're probably going to end on this one because just typing this out does take a while, guys. I'm really sorry. So this equals, because we want to have the same denominator, we're going to multiply this top and bottom by this denominator. So in other words, we want the denominator to be the same, so I'm just going to leave it as one denominator. You'll see what I mean in a second. So this ends up being 5 times 2x plus 1 plus 1. And then it's going to be, since it's 5 minus, I'm going to do minus. So again, this is my denominator. I'm going to subtract my numerator. So that's x plus 5. And this is going to be in parentheses. And this is going to be over my denominator, which is 2x plus 1. So what I'm doing here is because I want to add these together. I have 5 over 1 right here. So I'm going to multiply the top and the bottom by 2x plus 1 and 2x plus 1. So this denominator that didn't exist before now becomes this 2x. Oops, let me scroll down. It's not letting me scroll down. This 2x plus 1. So that's allowing me to add them together. So there's no point in me writing this denominator twice. That's why I'm just writing it one time. Does that kind of make sense, guys? I know it's a lot. I recommend if you're having trouble with this, make an appointment with me, or we can always you can always rewatch this. So that's just this top part. We still have to deal with this whole bottom part right here. This one, we're going to do something similar where we want it to be the same as over here. So for this has to be inside a different fraction. And I'm honestly just going to copy this right now just to make it easier. I'm going to copy that. I already controlled C. Now I control V. But now I want to distribute this 2 over, right? So I'm going to want to get rid of this, and I'm going to distribute that 2 over there. And because I want this 1 to be multiplied by the denominator, so let me kind of visually show you guys what I'm doing here. I'm doing here this 1 over 1, because that used to be right here. Scroll up. That used to be right here. I'm gonna, and with an invisible denominator, I'm gonna multiply both the top and the bottom by this x plus 1, x plus 1. So basically 1 times x plus 1, well, that's literally just 2x plus 1. And the denominator is 2x plus 1. So I'm going to leave those denominators the same. So that's all I do there. And now that I have all this work in, the only step I have to do on the top here is to distribute and then add. So there's literally, unfortunately, going to be one step where all we're doing is just distributing that 5. Could I have done that earlier? I could have, but well, I guess technically I can do the same thing here. I'm going to do it here. 1 times that. So I'm going to do the distributing now as the next step. And I'm really sorry, guys. They really should have done an option where you can take a picture. I don't know why they're not doing it. I'm going to allow you guys to do this to take a picture for the next one. Just so you don't have to write all of this stuff down. This is terrible. So I'm going to distribute this 5. And this is going to be 10x, that's 5 times 2x, plus 5. Don't forget that 1 there. A lot of people forget to distribute this 5 to this 1, and they just put plus 1. Then we have minus x. And we're also going to be distributing this negative too. So don't forget that it is minus x, but it's also minus 5. So right there, you can probably see that we're already going to be subtracting something. This, if you highlight all this, you don't have to worry about like messing with your fractions again. It automatically assumes whatever you highlighted is your numerator, your number on the top. And this is all over 2x plus 1. And now we're going to deal with the denominator. And this itself is a fraction. So now we can distribute those. I'm going to just go ahead and distribute. Well, I do have to distribute that negative. So I guess it's a good thing that I did put this -1 because I do have to distribute it. So the top part stays the same. So I'm literally just going to copy this, paste it. I'm going to copy this and paste it here, but I'm going to change it to negative because it's negative 2x and -1, because what we're doing here is we are literally just distributing this negative, distributing the negative. All right. And then from here, this is all over 2x plus 1. So I know this is like some really huge super fraction, but remember, when we have a fraction divided by a fraction, that's just the first fraction multiplied by the reciprocal of this. So our next step is equals, I'm going to simplify this. I'm going to do 2 steps. I'm going to reciprocate the bottom and simplify any terms just to kind of save some steps, guys. I don't know why they gave you one so big for this. I'm sorry. So here so 10 minus x is 9. So we have 9x by itself here. And that's going to be over. Did it not do the fraction? Oh, there we go. Over the 2x plus 1. Are you guys following along? Just let me know if you need me to slow down or anything. And from here, I'm going to reciprocate this. So reciprocate meaning I'm just going to flip it. That way we can multiply instead of dividing it. And the cool thing about reciprocating it, you'll see. So I'm going to put this in parentheses to kind of show that that I'm multiplying. So here I do, this becomes 2x plus 1. You'll already see here, I can already cancel these two out. So that's already a good sign. And then what happens here is 2x minus 2x, that goes away. And then we're left with just the 9 here, right? So what's going to end up happening here is our next step, we can cross cancel those. Delete that. So if we're going to cross cancel those, we end up getting equals 9x divided by 9. And 9x divided by 9, that's just x. So that long, complicated process is how we do this. It's a lot of work. So I'm going to show you guys eventually how to do it in a Google Doc. That way you can just write it down, take a picture and do it, because this is way too much work. So I'm going to click done on this one. It's going to say incorrect. But it honestly should be. Are you guys able to continue um, on this even though you don't get the correct on this one? You guys can't continue? So let's just do the answer. What about after you click the answer? Is it okay to continue after that? I just need to know what it allows you to do and what it doesn't allow you to do. I mean, I guess, and it stinks because all of this work is exactly the same. I think the only thing that's different is no, it actually is exactly the same. They inverse it, they do it the same, multiplied by the L. I think they're just doing it a little differently. Um, bu- 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 so, are you guys able to continue after that, or are you guys literally just stuck on this? Um, Anybody? Are you just stuck on this page, or does it let you continue after it gives you the answer? Either of you. I mean, I can try to do it the way they want us to do it. Let me see. That part's the same. That part is the same. Okay. So for some reason, they're cool with if you just leave the answer the same. Sorry, something. Okay. It's cool. Okay. That's fine, guys. So I did show you guys all that work, but apparently Admentum is cool with you guys just doing g of f of x equals x. That's all it wants. I guess it didn't care if you showed all your work or not. It literally just wanted this verification, and that's enough to say that's fine. Um, so moving on, but you would have to also understand how to do that. So I'm not going to go through the steps again because they're going to be very similar to the other one. So for this one, I'm assuming Admentum is cool with you just saying this. But I think it's just testing you mainly on the concept as opposed to you actually doing the work. So if you say f of g of x is equal to x, I'm pretty sure if you click done, yep, it says you're good. So you don't have to actually verify it. It's just like, do you know what happens if you put an inverse into the other thing, is basically what it's saying. And we have like 8 minutes left, but we got through like 19 pages. I know some of it is the videos and stuff. Um but yeah, so for right now, guys, try to mess with your tutorials just to see if everything's working out. Apparently, for problem one, if you just go g of f of x is equal, oh, another parenthesis, is equal to x, Admentum considers that the right answer. So that's the part where I didn't get it right, is because I didn't write this as my final step. But apparently, this is all Admentum's looking for this. But please review how to do it because it is important for when you're doing the unit activity and I'm grading that part. All right. So, oh, let me see. F of x is right. Um, so it would actually be the so for the first one, it would actually be f of g of x. Oh, this is problem number 2. I'm sorry. F of g of x is equal to x. This is what it considers the right answer to be. For the one before that, you just switch the g and the f. Does everybody kind of understand that? Good to go? Cool. All right, guys. Well, that's it for today. Tomorrow, or tomorrow, Wednesday, we will be finishing this up. So just review it, just understand what it means and stuff. I'll send a remind with the YouTube video in case you guys want to review this later. So let me stop recording. No, I don't want to stop sharing. I want to stop recording.